Okay, in mechanics we use vectors an awful lot because a lot of the units that we deal with are vectors. So let's just crack on with a little bit of theory. You would have covered this in the pure content, also at GCSE content, so I'm not going to spend a huge amount of time on this. A vector is denoted as a letter that's underlined, and when it's typed, so in a textbook or in an exam paper, it will be in bold. But when you're working, you should always underline your vectors. And we just deal with two-dimensional vectors for now, so I'll ignore any third dimensions. But we're going to say that this is equal to A times the vector I plus B times the vector J, where I and J are what's called the unit vectors in the X and Y direction. So J is equal to the vector 0, 1, and I is equal to the vector 1, 0. This type of vector is what is called in component form. Component form, and we can write it in column form as AB. It's column form, but they are exactly the same. Sometimes questions will give you column form, sometimes questions will give you component form, and you just need to be able to notice that they are exactly the same thing. But one thing I will advise is that if a question is dealing with all the vectors in column form, then your answer should be in a column form. And if your question is dealing with component form, your answer should be in component form, just for consistency. Okay. Occasionally we don't underline a vector. Occasionally instead you'll see a vector with an arrow above it. This means the vector from the point A to the point B. So the vector from point A to point B. Okay, which can be denoted as a separate vector, or defined as a separate vector. All right, so just be aware of that. If there's an arrow across the top, then you don't need to underline it because the arrow denotes that it is a vector. The magnitude of the vector. Okay, this is the size or the magnitude. Magnitude or size of the vector. And in this case, because I'm defining v as being ai plus bj, then it is equal to the square root of a squared plus b squared. That's just Pythagoras. Because what a vector is essentially can be depicted as an arrow, where it's moving a horizontally and it's moving b vertically. So the size of it is defined as the length of that arrow. And by Pythagoras' theorem, we can apply Pythagoras' equation and get the length of the line is the square root of a squared plus b squared. Yes. Okay. Right, adding vectors together. So let's say v is going to be equal to the vector AB and w is equal to the vector CD. Then we can add two vectors and we can say that v plus w is going to equal a plus c in the x direction and b plus d in the y direction. Okay, so simple as that. And then the pure content of the A-level course goes into a lot more detail about how you can kind of prove things geometrically using vectors. That's not done on the mechanics course. On the mechanics course, it is just a case of just using vectors in equations as opposed to proving things. So why do we need vectors in mechanics? Well, there are a number of quantities which are called vector quantities. So all units can be broken down into kind of a vector or what's called a scalar. And it's important to distinguish between the two. So a vector might be something like a force or a velocity or an acceleration. Whereas a scalar might be something like the temperature, the mass, the speed, or distance. We've also got displacement in vector. Okay, and a vector quantity in physics or mechanics is a quantity that doesn't just have magnitude but has direction as well. So it makes sense to have a size and a direction. For example, a force has, I don't know, 10 newtons in a certain direction. A velocity, it is travelling at 25 meters per second in a certain direction. Okay, so these have magnitude and direction, whereas the scalars don't. The scalar, temperature, for example, or mass, it doesn't make sense for an object to be 5 degrees Kelvin upwards. That makes no sense. Okay, it doesn't have a direction. It is just a magnitude. It is 5 degrees Kelvin. That is it. A mass, 20 kilograms. It doesn't make sense then to have a direction on that. Speed and distance are interesting because although it does make sense to have 5 meters per second in a certain direction, it is still classed as a scalar because what you do is you take the velocity and you apply Pythagoras' theorem, okay, up here, the magnitude, to become a scalar. So actually speed is the magnitude of velocity in the same way that distance is the magnitude of displacement. Okay, so speed and distance, they are scalars, and velocity and displacement, they are vectors. Okay, geometrically then, let's have a look at adding vectors together. So I've got 3 points here. I've got A, B, and C, and I'm told that the vector to get from A to B is 10, 15, and the vector to get from B to C is 5i minus 25j. And what I need to do is essentially just state what the vector is then to get directly from A to C. And geometrically, if you're adding two vectors together, then you move along one vector and then move along the other. Algebraically, we could just add the components together. So in the x direction, it's going to be 10 plus 5 is 15, and 15 minus 25 is minus 10. So the vector to get directly from A to C is 15 minus 10. And we could call this the resultant vector of these two vectors. And we'll look at a lot more detail about resultant forces and triangular forces a bit later on in the course. Alternatively, you might be given something slightly different. So we've got a vector to get from P to R and a vector to get from Q to R. Well, what then is the vector to get from P to Q? Well, what we could say is the vector to get from P to Q is equal to the vector to get from P to R plus the vector to get from R to Q. But we haven't got R to Q, we've got Q to R. So we actually need to write P to Q as in terms of Q to R, which is negative. Okay, if you swap the two letters around, then you're timesing the vector by minus 1. So to get from P to Q, I'm going from P to R, and then I'm subtracting Q to R to get to there. Another way to see it is the vector from P to R is P to Q plus Q to R, and then rearrange to make P to Q the subject. Okay, that also works. So in the x direction, we've got 15 subtract minus 10, which is 25. So just be careful with your signs. And then I've got minus 15 subtract minus 20, so that's going to be plus 20. So that's going to be 5. Okay, and that's the vector to get from P to Q. Okay, that's all I want to talk about on vectors. We're going to stop there. But you just need to be kind of confident with kind of adding, subtracting, and the use of vectors in maths. Okay, thank you.